With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, today we are going to discuss one more question. The question says that the function f of x equals to greatest integer function of x square plus minus of greatest integer function of x square, where this bracket denotes the greatest integer function is. So we have to find the function is differentiable or continuous at x equals to 0 or 2 here. So first of all, as we write here, f of x is equals to greatest integer function of x square plus minus of x square. This one is function given here. Now we have to find at x equals to 0. At x equals to 0, as we can see here, left hand limit. As we know that greatest integer function, graph of, as we can see here, this one is x-axis here and this one is greatest integer function x here. So the function is discontinuous at all integer point. This point is 1 here. As we can see here, function is discontinuous at 0, 1, 2, 3 and then so on. Similarly at minus 1, minus 2, minus 3 and then so on. So if we take here 0 minus h, let us take left hand limit. So in the left hand limit, x can be written as here. For the left hand limit, here we replace x as x minus h. So this one equals to 0 minus h. Let us take limit h is tending to 0 here, and this can be written as here f of 0 minus h here. So this can be written as here limit h is tending to 0. This one equals to here greatest integer function of 0 minus h square plus minus of h square here. Minus of here we take x as, this one is h here. X as h here, 0 minus h can be written as minus h here. So minus h square equals to h square here. So this one is here. So as we know that 0 minus h is little bit less than from 0, and whenever this one is little bit less than from 0, so this can be written as here minus 1 here. So this one is minus 1 and minus 1 square here, because greatest integer function of minus h equals to minus 1, so and minus 1 square here, plus minus of h square. As we know that this quantity is little bit less than from 0, so this one is the h square is also less than from 0, because if we take any quantity which is less than from 0 but greater than from minus 1, so the square is also between 0 to 1. So this quantity is also equals to minus 1 here. So this one is equals to minus 1, so here we get plus 1 and here we get minus 1. Plus minus 1 equals to 0. So this one is implying here left hand limit is equals to 0 here. Now if we take here right hand limit, so right hand limit can be written as here right hand limit is equals to limit h is tending to 0 and function is here 0 plus h. So this one is equals to limit h is tending to 0, and this one equals to greatest integer function of h square plus minus of h square here. As here we know that this quantity h is little bit less than from greater than from 0. So this quantity is equals to 0 here. So h is equals to 0 here. And now if we take here this one, as h is tending to 0 but little bit here 0 plus h here. So this one can be written as here 0 also. So this one is equals to 0. As we can say here, left hand limit equals to right hand limit, and if we find here limit of function when x equals to 0, this one equals to 0. So the function is differentiable, continuous at x equals to 0. Now for differentiability, right hand derivative. Right hand derivative is equals to limit h is tending to 0 f 0 plus h minus of f of 0 divided by h here. So this one is 0 minus 0 is equals to 0 here. Similarly, if we write here left hand derivative is equals to limit h is tending to, this one is 0 plus here and this one is 0 minus here. So limit f of 0 minus h minus of f0 divided by minus h here. Since f of 0 minus h equals to 0, f of 0 equals to 0. So right hand derivative is equals to left hand derivative. So function is continuous as well as differentiable at x equals to 0. So option A is here correct answer. Now come to the x equals to 2. If we check here for x equals to 2, the function is equals to here at x equals to 2. First of all, f of x is given as here greatest integer function of x square plus minus of x square here. So at x equals to 2, first of all here we find right hand limit. As right hand limit, this one can be written as here 2 plus h here. So this one equals to 2 plus h square plus minus of 2 plus h square here. As we know that 2 plus h square, in greatest integer function, any quantity which is greater than from h, 2 is equals to 2 here, because by the diagram of greatest integer function, as we can see here, any quantity which is much greater from 2 is equals to 3 here. Sorry, this one is equals to 0, 1 and this one equals to 2 here. So this one is equals to 2 here. So we can write it as here 2 square. 2 square plus minus of 2 plus h square. As we know that 2 plus h square can be written as here. As we know that 2 plus h square is little bit greater than from 4. And if this one is little bit greater than from 4, we get here f, let us take this one is equals to minus 4 plus delta. Let us take this one is delta quantity. Delta is little bit greater than from 0 but more less than from 1. So as we know that this quantity is equals to minus 5 here. So this one is equals to minus 5 here. So 4 minus 5, this one equals to minus 1 here. Now if we take left hand limit here, so left hand limit is equals to here f of 2 minus h is equals to here 2 minus h whole square plus minus of 2 minus h square here. So this quantity is equals to here 2 minus h square. 2 minus h is little less than from 1, 2. So this one equals to here 1 square. And this can be written as here, this quantity is little 4 minus delta here. So 4 minus delta, this can be written as here 4 minus delta is equals to minus 4 here. So this one equals to 1 minus, this one equals to minus 4 here. So this can be written as here 4 minus 1, this one equals to minus 1, and here is 1 minus 4. This one is equals to minus 3 here. So left hand limit does not equals to right hand limit. This one is implying f is discontinuous at x equals to 2. So by comparing from option here, we get function is not continuous at x equals to 2. This one is implying function is not differentiable at x equals to 2. So neither continuous nor differentiable at x equals to 2. Option B is also correct answer here. I hope you understand the explanation. Thanks for watching.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.